Hi, everyone. My name is Romeo Alvandepoel, but you can call me Rom. I think that's going to be easier for everyone, including my parents. Um, I'm a principal cloud architect at Ondat. Today, I have the pleasure of sharing with you customer stories and their challenges. Not going through super deep dive technical details, but explaining you how our pillars help them to transform and I would say accelerate their businesses. So we have three pillars: build on data, build anything and anywhere, and build at scale. I'm going to give you my own definition of it. We have our marketing and corporate way of defining it, but I'm going to give you mine and the one that we share with customer and how we onboard our customer with. So build on data, it's about making sure that our customers, who I would say 90% of them are developers or DevOps engineers, are first-class citizens. So those profiles usually don't have any knowledge about storage. When I say storage, I mean those big storage vendors. And for them, acquiring those skills might be an issue and might be slowing down their adoption of any storage technologies. Build anything and anywhere means removing any restrictions regarding what kind of application you can run on Kubernetes. There's a lot of urban legends flowing around that you can't run a database, for example, on Kubernetes. Or if you do so, you need to have a specific platform or leveraging specific service from a cloud provider. The last part is about building at scale. Building at scale, for some part of, I would say, of the implementation might have impact or trade-off on performance and resiliency and security. And this is something that we don't want to have. We don't want to share or tell a customer that there's any trade-off when you start scaling up to 200 plus nodes, or if you start having a database of 16 terabytes, or if you want to start having encryption at rest with some impact on the performance of databases or data set. So these are really important for us. I'm going to start with one that is very at my heart because learning, I think it's really important. And it's about an education agency. And that education agency is having a very old infrastructure. And when I say old, it's from the 90s. And they are all considered as remote branch offices. So 1,000 schools, 700,000 students using that infrastructure on a daily basis to access their profile, to access their exam records, to consume courses. So very, very complex environment, very complex to manage. About hundreds of people handling the day-to-day for those infrastructure, plus the people in the different schools that are not IT people. From that, we have 0.5 petabyte of data just for the records, accounting, and staff information. And they come up with the idea of reducing to about 10 SREs with no knowledge of storage vendors. They want to have the ability to build on anything they want. So they started with a specific stack, being some bare metal and SUSE and Rancher, but they don't want to have any limitation on this. They want also to be able to scale in an unpredictable way. And when I say unpredictable, it means that from one day to another, you might have 10,000 students firing an exam, but the next day you might have 300,000 students firing a course on that platform. So you can't really define or forecast exactly what you will need from, I would say, compute resource or storage resources and so on. So having a platform that is able to scale with this and being able to shift left, all the operational part without having any knowledge of any storage vendors, but just knowing the basic of Linux, the basics of Kubernetes, and handling that amount of, I would say, workload with 10%, it's quite amazing. And that's what I did. Another one is about online shopping. Online shopping is obviously something that we all enjoyed for the last 24 months, I guess, due to very bad virus, I would say. But here, we are looking at a specific market, a specific segment of people that are totally isolated on different islands that are usually shopping with physical point of sales and with a close kind of a network. We were approached by a distributor in Europe dealing with 7 of those overseas territories. It's like New Caledonia, Guadeloupe, the Martinique. There's a couple of others. And we're looking at the 2.5 million consumer that during COVID needed to consume basic needs like first needs like soap. I'm sorry to say that. Buying a desk to work remotely, buying a new modem or router, all those things that were not available at some point because of that closed network. The distributor kind of agreed that they were old school shop. And so they decided to spin up a startup. And in less than 9 months, they built a company, built an infrastructure, and started to shift all their existing environment to that platform. So on that slide, you can see that they are averaging a revenue of 225 million a year. In less than 9 months, they succeeded to contribute with that new infrastructure for about a growth of 20% of that revenue. And they did it with a specific stack when we were discussing about being agnostic and building anywhere and on anything. With Proxmox, I don't know if you ever heard that in production, but they did it, Proxmox, Debian, Rancher, and Elasticsearch, and Solar. All that stack, very specific, old stack also for some of the part and components, is running like on the daily basis, crunching millions of items in thousands of catalogs to make a marketplace available, not only for the consumer, but for the point of sales to buy and supply those goods to the consumer. Another one is about the defense side. And this story is quite an interesting one. Back in July, we received a mail from a defense agency in Europe asking us to supply them with a contract for having a support on this fantastic solution that they are running. And we were like, okay, so let's go through the discovery call and understand what you're doing and so on. They were running for the last 2 years a development, massive development to create a data exchange platform with instant messaging and voice end-to-end encryption for all the different institutions and companies that are contractors for that defense department. The beauty of it is that every pillars that we're discussed about, building on data, building anything anywhere, building at scale, is fitting the bill here because we don't even know what they're building. We don't even know where they are building it, and we don't know exactly what their size at some point. So we were running into a gray area with them. They couldn't share anything with us. But what we know is that they build Kube native and cloud native applications for those data exchange, instant messaging, and voice end-to-end encryption. We know that they're running on public clouds, and they need super security environment where they can guarantee that everything is fully encrypted end-to-end, and not only, let's say, encryption at rest on the disk, or we're speaking about the in-flight encryption from the container up to the disk, and then the encryption at rest for the actual disk itself. And they want a consistency approach for deploying anywhere because they are running across different contracts, obviously. And so today it's Azure, tomorrow it's on-prem, and the day after it could be in Google. So there's no, or even local hyperscalers. So there's no concept of consistency there. They run their own Linux distribution. Yeah.
I have a question regarding the encryption.
Yeah.
Because I'm just curious, since they are doing the encryption in all these different clouds, public cloud and also on-prem, are they using a consistent encryption solution across all of those environments? Do you know?
No, that's not the reason why they wanted to have that built in the storage, so that they don't need to come up with specific ways of configuring the encryption on the different cloud providers and making sure that they have one way to deploy it. So for example, with Ondat here, you just flip a label on your deployment and you're always certain that it's encrypted. So they can really enjoy that without the need of looking into Terraform for some environment and then some other tooling for other environment and so on. So that's the reason why they wanted to have that.
Okay, so they're using the encryption services from your platform to apply all that.
Yes.
Okay.
Instead of any others, because that would require from their GitOps approach to have specific configuration per environment and so on. Yeah.
Is your solution then leveraging any encryption services from the public clouds, or is that an entirely internally baked solution? Like where do the keys come from? Where are they stored?
That's a good question. So we,
I really do.
So the encryption part is, as I said, handled by labels. So when you want to deploy your stateful application, either on the storage class or the persistent volume claim, or in the actual deployment, you can set up the fact that you want encryption. The encryption keys are per volume group. So it's not like a master key for the overall solution. Mm-hmm. And so each time you provision a volume, you will have a dedicated key for the volume. And another key also linked to the namespace. So you have that 2 layers of making sure that we are looking at the right volume in the right namespace for the right workload. So that's something that we're doing. The keys are stored, and that's the moment you're going to say, "Oh my God!" The keys are stored in etcd, the Kubernetes etcd. Yeah. So
okay.
And that's oh my God moment, because we all know that it's not safe. It's just encoded in 64-bit, and that's it. So that's why we took the approach of the Kubernetes KMS provider plugin, where, so in that case, you don't need to have specific tooling. You don't need to put in place any specific operators from any other vendors. You can just leverage that provider plugin in place to store your encryption keys anywhere else. But in that case, you're not storing the actual encryption key of the volume. You're having a specific encryption key for the entire etcd. So you're securing at the same time the etcd. So we forced our customer to be secure in that sense. Yes?
Okay. Nathan Bennett here. Just a quick question, and I may have missed it. If I did, I apologize. Could we have just a real quick 5th grade description of what Ondat actually does? Is this an automation orchestration for storage class, persistent volumes, and all these different things that you just discussed with Ned? Or is it actually a storage provider that expands onto that area, or do I just connect it to whatever storage provider that I want?
It's both. So
I love it.
So it's both. So we have the orchestration part, and then we have the storage engine part. So the storage engine part, or the data plane, is actually looking into what you have on the different nodes as storage. It could be NVMEs, could be vDisk, EBS volume, whatever you can supply. It could be also the root file system. We'll not advise to use that, but
sure,
if you want to go cheap or development, you could do it. From there, we deploy as containers because we're fully software defined. We have a full container deployment approach with daemon set and so on. We look at that available storage pool on different nodes, and we'll consume it. So that's the data plane. From there, we also have the ability to replicate data from one node to another. That's what you're missing with, let's say, if you deploy on AWS and you want to provision EBS, you will have the EBS. You will need to have the EBS following the workload in case of failure. So in our case, we we remove the need for your developer to build a replication engine in the application. We're making that for you. So at that point, we are making sure that the data is available somewhere else.
Do you also support remote replication in the sense that with high latency, asynchronous replication, like in any other storage system, enterprise storage system that you could?
There's two things. So we support replication, first of all, it's synchronous replication. And the current stage is within the same cluster and across different availability regions. Between clusters, not yet there.
Okay.
Does it answer the question?
Yes.
Okay. So to come back to your question, then we have the orchestration part, where when you fire a deployment, what you do is that actually Kubernetes will ask to provision different elements based on the PVC, the voucher. Yeah. So I will always take that example with customers. You have a voucher for a Coke. Ondat is actually the shop. At the moment, you as a customer, the application in this part, you want to have access to the data or create data, you will need a volume, PV. In that case, you take your voucher, you go to Ondat and say, I want my volume, I want my Coke. And we provide it to you. That's the orchestration part. And we have much more things around the orchestration because as I was mentioning, the fact that we're using labels and not only tying you to a CLI or to the configuration of your storage class will allow you to make some changes, like if you want more replica for your volume, if you want encryption, if you want compression, you can define those as label anywhere you want, and we will pick that up and make sure that it's going to happen on the data plane part. Is it the fifth grade answer you were looking for?
Well, it definitely fits for what I'm trying to conceptualize here, because we see a lot of things out there in the market right now that say, hey, you can take your persistent volumes, and then bring in S3 or do the sun. And so it's good for us to just kind of conceptualize exactly what you're describing here. Where the question that we always kind of, or at least I always kind of deal with when we're dealing with Kubernetes is, where does Kubernetes stop and then your product take over? And that's a hilarious gray area where there's like, we work with them. And so it's very difficult to conceptualize that. And that's what I'm.
Yeah. A good solution, whatever it's for networking, storage, security, being a part of the abstraction layer of Kubernetes should not stop at any point in time to work with Kubernetes. So it should be fully integrated, should be kube native, should be able to address Kubernetes. As an example here, we were discussing about placement and replication of the data on the nodes. When you have a failure, I was mentioning the EBS failure where the EBS volume is moving from one node to another. If you had that failure, it's not only a question of saying, hey, the data is available there, you can reach out. It's also a question of saying it's a stateful set. There's a timeout associated in Kubernetes around this because there's an order of in ways you need to do things. And what we can do is to influence that order to say, you don't have to wait that amount of time to restart your workload somewhere else. We can just say to Kubernetes, to the orchestrator, say, restart the workload there because we know the data is there, the data is safe, we have a good consistency point, the attachment is available, you can reattach and refire the workload there. Instead of waiting at least 5 minutes, you're going to wait for 2 seconds. Yeah. So that, to me, you should not have a stop somewhere.
Yes, to be clear, what my definition is of where Kubernetes ends and your product begins is the CRDs, the custom resource definitions, right? Those are the things that you don't get out of the box with Kubernetes, just for those watching. Those are the things that, obviously you're providing via the operator and whatever manifest you want to state, right? And so that's kind of where I'm trying to gauge that's where, in my opinion, that's where Kubernetes or out of the box Kubernetes stops. And that's where y'all have to start picking up and saying, no, these actually do exist because this is how we say they exist, et cetera, et cetera.
Yeah. So I agree with you. From the day zero, that should be a stop there, and then it's part of our I would say secret sauce. And then from a day to operation, it should be totally transparent.
Like
Yeah,
that.
yeah.
Thank you.
You're welcome. So in this example from the customer from the defense, we're looking into making sure that everything is secure, is available, but also it's navigating in the gray area because we don't know exactly what they're running.